In this lesson, we want to be able to say that I can use the distributive property to evaluate and simplify expressions. So let's go over what the distributive property is. The distributive property says for any real number a, b, and c, if we have this happening, that a times parentheses of b plus c, this is going to be the same thing as saying a times b plus a times c. We are taking that value on the outside and giving it to everything on the inside equally. Because it's multiplying on the outside, it's going to be multiplied on the inside. Another way we could write this, we could write it as b plus c with the a on the back side. This one would be b times a plus c times a. And also remember the properties of multiplication. That could be a times b plus a times c. Order does not matter with multiplication. Remember, it's commutative. We could also have the same thing with subtraction. We can have a times b minus c. This is going to be the same thing as ab minus by ac. And lastly, we can have it in a different order. We could have b minus c times a. This would be ab minus ac. You could also write it as ba minus by ca. Okay, remember, multiplication is commutative. So that is one nice thing that we have. Here's an example. Let's say that we have negative 3 times by 2 plus 5. All we had to do, take that negative 3, give it to everything on the inside. So that would be negative 3 times 2 plus negative 3 times 5. In other words, this is negative 6 plus negative 15. So in other words, this would be a minus by 15. Negative 6 minus by 15 gives us negative 21. That's one way we could do it. Remember, we could have also did the 2 plus 5, which gives us 7. And 7 times negative 3 is negative 21. Both ways work. But the distributive property can help us to simplify a few nastier numbers, which we're going to see here in a moment. Let's look at this example. Ethan reads every night before bed. Each night he reads 30 minutes of a novel and 8 minutes of a magazine. He reads like this for 5 nights per week, for 5 nights a week. Use the distributive property to write and evaluate an expression that demonstrates the total number of minutes Ethan reads each week. Okay, well, we're just going to set up our expression. Each night he reads 30 minutes of a novel. So let's say that's 30 of the novel. And let's say 8 minutes of the magazine, right? He reads like this for 5 nights a week. So let's take this and put it times by 5. And we want to use distributive property to write and evaluate the expression that determines the total number of minutes Ethan reads each week. By the way, we don't technically need the variables in this one. We can take the n and the m out because that would be just representing the books. Well, he's just reading one book at a time, 30 minutes of one, 8 minutes of the other. So 5 times 30 plus 8. We could go 30 plus 8 and then times that by 5. That works perfectly. But if we want to use the distributive property on this, 5 times 30, 5 times 8, so this would be 5 times 30, let's write that down, plus 5 times 8, which would give us, 5 times 8 is 40, 5 times 30, 5 times 3 is 15, just put a 0 behind. Add those together, this would be 190. This is a whole lot easier to solve it this way, with this problem, than to solve it 30 plus 8 times by 5. That's a little bit more challenging. That's a little bit more difficult for us to think about how to solve 38 times 5 versus 5 times 30, 5 times 8. Let's look at this one. Use the distributive property to rewrite the following, then evaluate. Let's make this a little bit easier. Here's what we're going to do. We're going to leave that 15 alone for now. And what we are going to do, we're going to put in parentheses. 72 is 70 plus 2, right? So 70 plus 2 can go on the inside. That's going to be a whole lot easier to solve versus going 72 times 15. Break it apart. Make it easier steps for yourself. So now what we can do, we can just distribute that. So that this would be 70 times 15 plus 2 times 15. And 70 times 15, okay, 15 times 2, let's go ahead and do 15 times 2 first. That's 30. So this would end up being 75 with a 0 behind it. Right? So 15 times 2 is 30. Times 4 will be 60. Then add 50 more onto that. Let's just do that really quick. Times 15. Just to make sure. 5 times 0, 0. 5 times 7 is 35. 0, 1, 7. It's going to be more than that. I need to make sure we do that right. That's going to be more than 750. This is 1,060. Double check your work. Add these together. That's 1,090. And that would be that one distributed. I know that one was a little bit harder. But if we think about what each number is doing, it makes it manageable. Okay? This next one. 20 times 4 3/4. This is saying that 20 times 4 plus 3/4, right? That's 4.75. 3/4 is 0.75. So that is 4 plus whatever that decimal is. So let's distribute that. Distribute this. Take that. This would be 4 times 20 plus 20 times 3/4. Multiplying this out, 4 times 20, 4 times 2 is 8. Put the 0 behind, so that's 80. Then 20 and 4, that has 4 in common. So this would be 5. 5 times 3 is 15. So add those together, this would be 95 for that answer. Okay, we're just breaking it apart. We're putting it as an addition of two numbers and just distributing it along. For this one, for part C, we can do something very, very similar. We also need to think about, while we're doing this, think about what numbers could be easier. We could rewrite it as a 100 plus a 90 plus an 8 times 6. We could rewrite it like that. Or we could write it like this. We can say, well, 198 is 200. Let's minus that by 2. That's a little bit easier to think about, a little bit easier to solve. So finding this little trick can make things a lot easier. We have 200 times 6 minus by 2 times 6. So this would end up to be 2 times 6 is going to give us 12. And this is going to be a subtraction. 200 times 6, we're going to have 12 with 2 zeros behind it. So in other words, all we now have to do is just do a little bit of a subtraction problem. So we had to borrow. This would become a 1. That's a 10. Actually, it's a 9. That would be a 10. 10 minus by 2 is 8. This would be 8. This would be 1 and 1. So our answer is 1,188. It helps us to be able to find solutions to bigger numbers quicker. So that is one way we can use the distributive property. Let's look at these. In this example, we want to rewrite each expression using the distributive property, then simplify. This one's actually a little bit easier because it gives you what you're going to be doing with the distributive property. We're just going to distribute this so that it's a negative 7 times that 3x, then a negative 7, so plus a negative 7 times a negative 8. So in other words, this is a negative 21x. Negative times negative is a positive. 7 times 8 is 56. That's all what that one is. Like I said, it's a little bit easier than the last ones because we're not making the distributive property. This one, they give us the parentheses. All we had to do is actually use the property on this. Part B. We can distribute it along 2 things. We could also distribute it along 3 things. So this right here would end up to be 8y squared times 5 minus by y times 5 plus 3 times 5. Okay, so in other words, this is 40y squared minus by 5y plus 15. that is the answer to that expression using the distributive property. We're just taking that 5, multiplying it to everything that is inside. 5 times 3, 15. 5 times y is 5y. 5 times 8 is 40. Let's remind ourselves a little bit about a few things. An expression. Remember, an expression is a mathematical phrase that combines numbers, variables, and operations like plus, minus, multiply, divide, but does not include an equal sign. Okay, so it has numbers, it can have variables, it can have operations. An example of this could be like 3x plus 1 expression. By the way, all what we've done above in the last part of this lesson is we've been working with expressions. Yes, we've been saying that this is equal to something, but the element by itself, like up here, this is an expression. 8y squared minus by y plus 3 is an expression, and so on. A term. A term is a part of the expression separated by an addition or subtraction. So the terms of this one, 3x is a term, 1 is a term of the expression. Just quick reminders of what we have. Like terms. What is meant by a like term is that they have the same variable and with the same exponent. For example, we could have, let's say, 3x plus 7x. These are like terms because they have the same variable raised to the same power. And this can simplify down to 10x. We've talked about this before. Simplest form. Simplest form is whenever we have no more like terms. So simplest form of the example we did up here is 10x. That is simplest form because there are no other like terms in that expression. Another example of this, if we have 3x squared plus 5x plus 7x, that's not in simplest form because 5x and 7x have the same variable raised to the same power. So simplest form of this new example is 3x squared plus 12x. This would be simplest form of that expression. Let's look at a few more examples. Simplify the following expressions. Negative 3a minus by 7a. These are like terms. So let's combine them. Negative 3 minus by 7, those are both negative, so this is going to be a negative 10a. It goes farther negative. We owe them $3, we owe them 7 more, so put them together. So that's simplest form for that. For this part B, notice we have 2 of them with x squares. It's nice that addition is commutative, so we can put those together. 19 minus by 3 is going to end up with 16x squares. Notice this 2, nothing else with just 2, or nothing else without variables. This negative 5x, there's no other just x. So this would be minus by 5x, and then we go plus 2. Typically, we write it, for standard form, we write it as the highest power first, which is a square, and we work our way down in powers. So we have the square, then we have the first, then we have nothing. Okay, this is typically how we write it. We start with the highest power, which would be square in this case, and we go down in powers. Let's look at this example right here. In this example, we want to use the expression negative 3 times the sum of x and twice y. Then we're going to increase the sum by 7 times the difference of 5 times the 4th degree of x and 2 times y. That is a mouthful. That is a lot right there. But if we've been practicing, we should be able to do this one. So negative 3. Negative 3 times. What are we timesing? We're timesing a sum. We're adding things together. Well, the sum of what? X and twice y. X and twice y. Remember, that would be 2 times that y amount. That's the first part of this expression. Second part is we are going to increase it, so that means add, by the sum increase that sum. So we're increasing this by 7 times. 7 times, so 7 times something. We're doing the difference. Difference is subtraction, so we're going to subtract something from another thing. The difference of 5 times something, 5 times the 4th degree of x, so x to the 4th. And lastly, 2 times y, so 2y. Break it apart. Take the words, do each section, and see what happens. So this part A, write an algebraic expression for the verbal expression. We just did that. We just wrote the algebraic expression for this. Part B, simplify the expression, meaning make it so it has no like terms. Put everything together if we can. So what we are going to do is we are going to do the distributive property. I'm going to just rewrite it real quick so that we have it down here. Plus 7 times 5x to the 4th minus by 2y. We're going to distribute this into the parenthesis, distribute this one. And this will give us, okay, negative 3 times x is a negative 3x. Negative 3 times 2y is going to be a negative 6y, right? Negative 3 times 2 is negative 6. We are going to add this to 7 times 5x to the 4th. 7 times 5 is 35. X to the 4th. And positive 7 times negative 2y. 7 times negative 2 is negative 14y. Okay, we got rid of all the parentheses. That's part of simplest form, and having it in the simplest format. The other part is, do we have any like terms? Anything with the same variables raised to the same powers. Well, let's look at this x right there. There's another x in there, but this x has it to the 4th power, so we cannot put them together. Those are not like terms. So let's just write down this negative 3x. Also notice this 35x to the 4th. There's no other x to the 4th, so this would be just 35x to the 4th. Remember I said a little bit ago, we want to try to put highest powers first. So we're going to put highest power, then we're going to go lowest power, and then we're going to put the other variable. Negative 6y. Are there any more in this expression that just have a y value? Well, yeah. This negative 14y. Negative 6 minus by 14. They're both negative, so we're going farther negative. So this would be a negative 20y. There are no more like terms. So this expression is now in simplest form. Always put like terms together. If we want it in simplest form, we have to get rid of all the parentheses and put everything together. Just recap. Properties. Here's our properties of numbers. This is to recap everything we've talked about this far. Commutative property. Commutative property says that if we have a plus b, it's the same thing as b plus a. Does not matter the order. Okay? Does not matter. 5 plus 7 is the same as 7 plus 5. Multiplication. A times b is the same thing as b times a. 7 times 5 is the same thing as 5 times 7. Does not matter the order for multiplication. Associative property. If we have a plus parentheses b plus c, this is the same thing as saying if we did a plus b plus c. It does not matter which ones we associate with each other first. Multiplication is very similar. A times b times c. Does not matter if we do the b times c first or if we do the a times b first. Does not matter how we associate these. Identity property. For addition, what makes it so that we do not change the value? If we have 3 plus something, what is that number that gets us to stay with 3? Well, that's 0. So our identity is 0. The multiplicative identity is, let's say, if we have 5 times something, we need to end up with 5. So the multiplicative identity is 1. I'm going to change these so that they're variables now. So instead of putting 3, I'm just going to put in general a. Instead of putting 5, I'm going to put in general a. The multiplicative identity is 1. The identity for addition is 0. The 0 identity, if you multiply anything by 0, you always end up with 0. Okay, that's the 0 identity. Distributive property, this is the one we just did today. This one says that if A times B plus C, if we have that, then this is the same thing as A times B plus A times C. So just quick recap. And substitution, last but not least, if A is equal to B, then we may put A in place of the value of B. Example of that one was if we say x is equal to 5 and have 3x plus 1, we can take the 5 and replace that x with it. So this would be 3 times 5 plus 1. Replace the value we're substituting. So this is 15 plus 1, which would give us 16, and that is evaluating that expression.